Hi everyone, this video is going to be on the Flute Power Analyzer for AC circuits. For your lab competency number 2, you'll be using the power analyzer to take all measurements from your AC circuit, and so we want to make sure we have a good understanding of the calibration and setup of this instrument, and also how to use it to make different measurements for both power, reactive power, current, and even phase angle for a AC circuit. So to begin with then, I'm just going to make this first video about the setup and calibration of this instrument. Okay, so first of all, if we look on top of the power analyzer is where we have two input channels, they're called. One of the input channels being called channel A and the other one being called channel B. When it comes to channel A, what we have is connections for 2 voltmeter leads to measure voltage in a circuit. And so if you can see here, I've connected 2 safety leads for my voltage measurement, and those are 1-to-1 leads with no attenuation or no extra device connected in series with them. They're just 1-to-1 test leads. So they're just a straight piece of wire. So we'll have to keep that in mind when we do a calibration or setup of this machine to make sure that it's set up accordingly, understanding that the voltmeter leads are just 1-to-1. So I've got those set up. Now the reason why I use test leads once again is so that you can connect it to a circuit and hands off continue to have a voltage measurement while you record your readings and do other connections and so on. If you use the probes, which are those pointy test leads, obviously you have to hold it and get a good connection during the whole time. So I always recommend using these, and I would just make it by default what you do all the time. So that's going to be your input channel A, and then your input channel B is where our current probe goes. Okay, now the current probe is a 2-part connection, if you will. It has a banana jack that you push in just like these voltmeter leads, but in order to connect the current probe, you need to include this adapter here. So this is an adapter that pushes in, and then it changes it to a B and C connection. So it changes it to what's called a twist and lock bayonet connection called a B and C. So you can see that when you look closer at that connector. So the first thing we need to do is we need to understand that this adapter needs to be inserted into the input B channel in order to connect the current probe. Now once it's connected, look how far you need to push it down. It needs to be pushed down that far. If you just push it in a little bit, you won't get the proper connection for the current probe. So you can see I pushed it all the way down till it's flush there at the base. So then from there, what you do is you take the current probe lead and you push it down and twist to connect it. And you'll know it's connected if you pull on it, and it won't come apart there. So you push down and twist, and the bayonet holds it in place. Okay, so now it means that we've got our power analyzer set up properly for channel A and channel B, and now we just have to go in and make sure the instrument is understanding or set up properly with those test leads that are connected there. Okay, so I'm just going to change up the perspective of this screen. Okay, picking up from where we left off, here we have the power analyzer. You can see up top I have those 1-to-1 voltmeter leads connected on input channel 1 there, or input channel A. You can see it marked 1 there. If you look over at where I have the current clamp, notice how it's marked 2. So the power analyzer uses both A to indicate channel 1 and B to indicate channel 2, but you need to understand you'll see both representations when it comes to the menus, both channel A and channel B, and channel 1, channel 2. 1 corresponds to A and 2 corresponds to B. Okay, so the next thing I'm going to do is turn it on with the power button. And one thing to be aware of is you will not have reliable power to this device unless you make sure that the power connection on the right hand side right here is fully inserted and you're plugged into a power bar with power. If the power analyzer turns off on you consistently, it's because it's operating on its battery, and none of the batteries are very good in these analyzers anymore, so they won't last. So you got to make sure you have AC power connected there and make sure that's pushed in firmly to give you the power you need. So notice how I went when I first turned this on. The power analyzer is wanting to confirm that I have 1-to-1 voltmeter leads connected, and that I have a current clamp connected to input 2. So it's confirming that, and we know that's correct. But what we need to do is go in and make sure that the calibration settings or the sensitivity settings are properly set for the configuration we're going to use. So that's what we're going to do now. So then you just hit the enter button, and then you're going to go to menu. So when you push menu, notice it brings up this menu, which we'll get very familiar with because we're going to be using, going into this menu for power and using the oscilloscope and for volts, amps, and hertz. But I'm going to scroll down all the way to instrument setup to start. And this is where I'm going to set up and calibrate my probes and make sure they're right before I start anything. And it's so important to doing this before you start any lab. So I'm going to hit enter. On the top it says probes, so I'm going to hit enter there. Notice how probe on number 1 is where we have our voltmeter test leads, and in this case I'm 1-to-1, so I don't need to do any changes. But if I had an attenuator in there that's going to drop the signal by a factor of 10, then I'd have to tell this instrument to do so that it's going to take that into account and doesn't give me the wrong value for voltage when I measure voltage. So essentially with this setting, one way to determine if you've forgotten to do this is if you see factors of voltage in a circuit of where you only have, say, 50 volts AC, if you end up seeing it showing up as 500 volts AC, or things of that nature, it's telling you that something's wrong with your calibration. So in this case, I'm 1-to-1, so I want to make sure it's that setting. And now I use the arrow button to go over to the current probe. Now, the current probe is where it's all relative to the setting on the probe. So this is where you turn on the probe on the top, and what you want to look for is a solid green light. And you can see I have a solid green light here. That's the first step. What I want you to always use by default is to push the switch all the way up to the top and be using the 100 millivolts per amp setting. 100 millivolt per amp setting. Okay, so once that's set up there, what we need to do is go to our power analyzer and set it to the same setting. So notice how we have 100 millivolts per amp here. We have to select that by hitting enter, and I always think it's a good idea to go back in and just make sure that setting was set for the device. So you notice how I just went back into that instrument setup again and verified I have a 100 millivolts per amp. Okay, so once you've done that, then you can just go back in your menus to volts, amps, hertz. Now, in the menu, if you didn't end up back at volts, amps, hertz and some other menu or some other function, just go into menu and take yourself to volts, amps, hertz and hit enter. Okay, now if you look at that current measurement right now, we don't have the probe connected to any active circuit. And so what we have to do is use this zero steering wheel, I call it, on the top to zero that value to what we're aiming for as a value of current that is below 5 milliamps. And you can see right now it's showing 65 milliamps. Now, one thing that's going to help you is this line you see here, because this line will either be below or above this zero line. You can see it's marked 0 there. It'll either be below or above, but the value won't change from positive to negative. So you can use that to help you understand which way you need to turn the wheel in order to bring it to 0. So in this case, because it's below, I'm going to turn it clockwise to bring it closer to 0. So that's what I'm doing right now. is I'm adjusting this wheel and I'm turning it clockwise this way in order to bring it closer to 0. Now, when you do this, you should keep the probe steady and not move it around, because you can see what happens if I move it around. I'm waving this thing around right now, and you can see how it's changing the current all over the place, and that's because it's sensing a changing magnetic field. So what I want to do is keep it steady, like I am. Just set it on your bench, and I want to continue to turn that just up a little bit to get it closer to that 0 value. So I'm just giving it little tweaks now to try and get it closer to less than 5 milliamps, right? So you can see now that I'm getting close, and I may have overshot it a little bit, but it looks like I'm able to have it steady out at less than 3 milliamps now. Now, it doesn't mean you have to add 3 milliamps to any of your current readings. It just means that you're properly zeroed as far as this current clamp goes. Okay? So once I've done that, that completes my calibration and setup of the power analyzer. And now we're ready to use it in our AC circuits for voltage AC, current AC, power AC, and what I will demonstrate for phase angle for AC. So this concludes the calibration of, and this is something that you should get familiar with. You should watch this video at least a couple of times so that you're fully familiar with doing that, because for your competency, for your last competency in this course, you need to be able to do that all on your own and set it up properly. Okay?